Now that we've looked at congruent triangles, proofs, and similar triangles, we're going to take a minute to review everything that's in this unit to help get ready for our test. So to begin with, congruent triangles. Remember, when we talk about congruent triangles, our different ways of proving them congruent are side, 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 where all three sides are the same. Side, angle, side, where two sides and the included angle that touches both of those sides are the same. Then we have angle, side, angle, where two angles and the included side are the same. And angle, angle, side. Now remember, we did talk a little bit about hypotenuse, leg, but that's not going to be on our test. Alright, so we have these four options to choose from whenever we prove triangles to be congruent. So if I look at the first of the three, okay, I've got vertical angles here that are already labeled. I have the angles in the corners that are labeled, and then these sides. Okay, so that tells me I have two angles and a side, which narrows it down to these two, but the side is not included, so it only touches one angle. So that means that these are similar by angle, angle, side, or side, angle, angle, same thing. For the second one, I have all three sides are the same, so they're congruent by side, side, side. And for the third one, I have two sides and the included angle, so that one's going to be side, angle, side. Now remember, this may look like a right angle all day long, but unless it tells you it's a right angle, you can't assume that. So this one is congruent by side, angle, side. Then we talked about the missing pieces. Okay, so telling, like, I want this first one to be congruent by angle, side, angles, but it's missing one piece of information. So if I look at what I'm given, right now I have the two congruent sides, and I know I have vertical angles. So I have an angle and a side, which means I'm missing my third angle, or my second angle. And I want that angle to touch the side as well. That side needs to touch both angles. And that angle would be angle T and angle E. So I'm going to say angle T needs to be congruent to angle E in order for these two triangles to be congruent by angle, side, angle. For the second example, I want them to be congruent, and we're going to take away LA, and we're going to say angle, angle, side. So right now I have an angle, so that means I need my side, and the side is not going to be touching both angles. So I have two options. One option is this side over here. Alright, I could say that IS needs to be congruent to TE. That would give me angle, angle, side. Another option, you don't need both, you just need one or the other, is this side over here. It only touches one angle. So I could say that XS would be congruent to TN, and that would also make them congruent by angle, angle, side. Then we talked about proofs, and remember we do two-column proofs, so we make our two columns. On the left-hand side, we have our statements. On the right-hand side, we have the reasons for those statements. So if I start with this, I have a given that it's isosceles, WXZ is isosceles, and it tells me that XWY, which would be up here, is congruent to ZWY. Okay, so WXZ is isosceles, so we're going to make it isosceles, and then I have those angles that are the same. Alright, I also have a reflexive property in the middle. This alone is enough to prove my triangle is congruent by side, angle, side, and that's all I want to do, so I'm going to start writing my proof. Always start with your givens. So we have triangle WXZ is isosceles. That's a given. Then we have angle XWY congruent to angle ZWY, also a given. And because it was isosceles, I was able to label these two sides congruent. So I'm going to say WX is congruent to WZ, and that's by definition of isosceles, because it told me it was isosceles. And then the third thing I labeled was that middle line, so WY is congruent to itself, WY, and that's by the reflexive property. And that was enough to prove my triangle is congruent. So my last line is always going to be whatever it wants me to prove. So triangle WXY is congruent to triangle WZY, and that's because of side, angle, side. another proof, but this time instead of proving triangles congruent, I'm proving that specific segments are congruent. So that means I'm going to use CPCTC at the very end of my proof. So to start with, PQ is congruent to MN, which they've got labeled, and then the measure of angle P and the measure of angle M is 90 degrees. So they are both right angles. Right? I also have vertical angles. And then with this information, they're congruent by angle, angle, side. Once I know my triangles are congruent, I know that corresponding parts, which would be QL and NL, they must also be congruent. So I'm going to put my statements and my reasons. Start with my given. So the first one is that PQ is congruent to MN, and it's a given. Then we've got the measure of angle P equals the measure of angle M, and they both equal 90. That's a given. Remember, red flag, anytime we have a 90-degree angle, that's a red flag, because just stating that they're 90 degrees doesn't state that they are congruent. So my next line needs to say that angle P is congruent to angle M, and that's because all right angles are congruent. So that's my side, that's my angle, and then my third piece is the other angle. Now I can't label it angle L because I have multiple angles in the middle. So I'm going to put L in the middle of my three letters and call this one PLQ. And then this side we'll call NLM. And they're congruent because of the vertical angles theorem. That was enough to prove my triangle's congruent. So I'm going to write my congruent statement, which I have to put my letters in order. So if I go QPL, all right, I went on the one dash to the right angle, then to the one curve. So one dash to right angle to curve would match up to MNL. And they're congruent by angle, angle, side. Once I know my triangles are congruent, then I'm going to end with whatever it wants me to prove, which in this case is that QL is congruent to NL, and my reasoning is CPCTC. And the last thing we talked about were similar triangles. So remember, congruent means same shape, same size. Similar means it's the same shape, but a different size. And we use angle, angle, and then side, 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 angle, side. But remember, with congruent triangles, those sides and angles all have to be the exact same. For similar triangles, the angles have to be the same, but the sides just have to be proportional. Alright, so for the first one, I've got these three side lengths and these three side lengths, and so I'm going to line them up. I'm going to start with the smaller ones. So the smallest of the first one is 42, and the smallest of the second one is 21. Then the middle side would be 56, and the middle side over here is 28. And then the longest side is 96, and the longest side over here is 48. So all of these need to be the same ratio for this to be a similar triangle. So if I divide, 42 divided by 21 is 2, 56 divided by 28 is 2, and 96 divided by 48 is 2. So all of those are the same, so these are similar triangles, and they're similar by side, side, side. If I write my similarity statement, order matters. So if I go YZG, and my similar symbol is just the squiggle without the equal sign, and I went short side to middle side. So short side to middle side would be RBP. If I look at the second example, in this case I'm given an angle in the middle and the two sides that make that included angle. So if these are similar, they would be by side, angle, side. So I still need to write my proportions. So 3 would go to 6 and 4 would go to 8. 3 over 6 becomes 1/2. 4 over 8 becomes 1/2. So these are similar by side, angle, side. Right? And these aren't labeled, so we won't worry about a similarity statement for this example. Then we use our similar triangles, the information we know about them, to find missing sides or missing lengths. All right, so in this case, I know that these are two similar triangles, and I want to find this question mark. So I'm going to call that question mark X. All right, so I've got this smaller triangle and the bigger triangle. The sides that I do know are 10 and 15. So that's going to be one of my fractions. So 10 to 15 has the same ratio as 12 to this whole side x. So we'll say 10 over 15 equals 12 over x. And I'm just going to simplify this fraction over here to make my numbers a little smaller. So 10 over 15 simplifies to 2/3. And so 2/3 has to equal 12 over x. Cross multiply. 2x equals 36. Divide by 2. X equals 18. So this whole distance over here is 18. And for our last example, we have a word problem. So on her trip along the East Coast, Jenny stops to look at the tallest lighthouse in the U.S. located at Cape Hatteras, North Carolina. At that particular time of day, Jenny measures her shadow to be 1 foot 6 inches in length, and the length of the shadow of the lighthouse to be 53 feet 6 inches. Jenny knows that her height is 5'6", and she wants to know the height of the lighthouse to the nearest foot. So we've got a picture drawn for us. So this is where Jenny's standing, and she's got her shadow lined up with the end of the shadow of the lighthouse. So I've got two similar triangles, the small one here and the big one that includes the lighthouse. So I'm first going to get all of these in the same either all in feet or all in inches. And since all of them are 6 inches, that's all half a foot. So I'm going to change 1 foot 6 inches to 1.5, 53 and 6 to 53.5, and 5 and 6 to 5.5. Okay, so the shadow of Jenny, 1.5, has to relate to the shadow of the lighthouse, which is 53.5. And that's going to have the same ratio as the height of Jenny, which is 5.5, and the height of the lighthouse, which is x for right now. Then we're just going to cross multiply. So I get 1.5 times x equals, and 5.5 times 53.5 is 294.25. Then I'm just going to divide by 1.5. And we get 196.17. And it wants it to the nearest foot, so that's going to be 196 feet approximately, according to Jenny's height and her shadow.